In this video, I'm going to be going over several examples on how we use properties of exponents in order to simplify different expressions. So let's just hop right into an example. So let's say that I have the expression 3x squared times 4x cubed raised to the third power. So I'm going to be using several rules of exponents as well as the PEMDAS operations procedure in order to simplify this expression. So the first thing that we need to do for this is to use our parentheses and take care of those first. So I notice that I have a 4x cubed inside the parentheses, which is all one term, but it's raised to the third power. So we're going to use the fact that if you have some number raised to a power and then you raise it to another power, then your result is that base raised to the product of the two powers. So in this case, what I'm left with is a 3x squared times 4 to the third power, which is 64. And then, using that rule, I have x to the ninth. And the reason that I have 64 here is because the third power is distributed to both these terms. So now what I'm left with is a 3x squared times a 64x to the ninth power. So multiplying the 3 times the 64 is just like normal, and that's going to give me 192. But when I multiply the x's together, I have to use this rule. So when you have some number raised to a power, and you want to multiply it by that same base that's raised to another power, then this is equal to that base raised to the sum of the two powers. So what I'm dealing with is an x squared times an x to the ninth power. So using this rule that I just wrote, I'm going to get x to the 11th power, because 2 plus 9 gives me 11. So notice how I'm still carrying out the PEMDAS and the GEMS order of operations here by taking care of the parentheses first and then dealing with any sort of exponents that I have. And then once I distribute the exponent, then I carry out multiplication operations. And it turns out I don't need to add anything, so the addition and subtraction operations aren't needed for this because once I carry out multiplication and division, this is fully simplified. So let's say I have this expression. I have 5y to the 6th power divided by 10y. So the 5 over 10 part is easy because that just reduces to 1/2. So this is the same as rewriting y to the 6th over 2y. So I have a y to the 6th on the top and a y on the bottom. And this is going to give me y to the 5th on the top over 2. And the reason for that is because of the rule that if I have some base raised to a power divided by that same base raised to another power, this is the same as me writing that base raised to the difference of the two powers. And in this case, I have 6 and a 1. 6 minus 1 gives me the y to the 5th on the top. So let's say I had 3a raised to the 2nd power multiplied by 6a cubed. So the first thing I'm going to do is distribute the second degree exponent in the first term. So when I do that, 3 to the 2nd power gives me 9, and a to the 2nd power gives me the a squared. So now I have to move on to multiplication. So I have a 9 times 6 in here, which gives me 54. And then I have an a squared times an a cubed, which gives me a to the 5th. So remember, when you multiply the same base with two different exponents, then you add the exponents together. Let's say I had 36 x to the 5th divided by 9 x to the 10th. The 36 over 9 reduces down to 4, so I'm going to be left with a 4 on the top. So I have 4x to the 5th divided by x to the 10th. So the same rule applies. Since I have an x to the 5th on the top and an x to the 10th on the bottom, this is going to reduce down to 4 over x to the 5th. And this is because I'm using the quotient rule. If you have two numbers that are the same but raised to different exponents, then it's equal to that number raised to the difference of the exponents. And in this case, I have 5 minus 10, which gives me a negative 5. But to write that as a positive exponent, I write that in the denominator, so I have x to the 5th on the bottom instead. Let's say that I had negative 2z raised to the 3rd power. So in this case, all I have to do is distribute the exponent to both of the terms. So I have a negative 2 raised to the 3rd power, which gives me a negative 8. And then z raised to the 3rd power is just z cubed. And that's all I have to do for this expression, because there aren't any other terms for me to multiply or divide in order to simplify this. And the reason why the negative stays is because essentially what I'm doing is multiplying negative 2 by itself 3 times. And so these two negative numbers yield a positive number, but I still have the negative 2 out in front, and a positive times a negative yields a negative. Let's say I had 8y to the 0 power over y squared. So one of our rules that I had in the beginning was that anything raised to the 0 power is equal to 1, and that includes this. So I distribute the 0 power to both terms, and I end up with 1 times a 1 on the top and a y squared on the bottom. Well, 1 times 1 just gives me 1. So my final answer is going to be 1 over y squared. Let's say that I had the term x plus 2 squared raised to the 3rd power. So I have the term x plus 2 squared inside the brackets. So what I'm going to do is I'm going to raise this entire thing to the 3rd power. And we're going to use the rule that if you have some number raised to some power and you raise it to another power, this is equal to that number raised to the product of the two powers. So in this case, I have x plus 2 squared, and I'm raising that to the 3rd power. And 2 times 3 gives me 6. So what I'm left with is x plus 2 raised to the 6th power. Last one. So I've got 40 times b minus 3 raised to the 5th power over 75 times b minus 3 raised to the 2nd power. So the 40 over 75 reduces to 8 over 15. So I have 8 times b minus 3 to the 5th power divided by 15 times b minus 3 to the 2nd power. So notice how I have a b minus 3 to the 5th on the top and a b minus 3 to the 2nd power on the bottom. So if I say that a is equal to b minus 3, then I can carry out the quotient rule. So if I have a to the 5th over a squared, this is the same as a raised to the 5 minus 2. And if a is equal to b minus 3, then I can apply that rule here. So what I'm left with is 8 times b minus 3 raised to the third power divided by 15. So I hope this video was helpful in determining some of the rules and some of the things that we do to simplify some expressions with exponents in them. So we still carry out the same order of operations that we would with any other algebraic expression, except we have a few rules to put in place whenever we're dealing with exponents. So I hope this video was helpful in giving you some examples on how we do that. And I'll see you for the next video.